I always had that. Yeah. All right. So I would like to finish it off the notes from yesterday. I know this class we didn't finish. So I want to talk about those things before we finish going over the homework. So first thing I would like to talk about is what did we finish yesterday? Average velocity or no? Yeah. Okay, so do we talk about average acceleration? No. Okay, so I'm gonna pick out there. So average velocity is equal to the changing of position over changing of time. Let's say you're going from here to home, right? It's like 5 miles and takes like 5 minutes, then whatever it is. So it's gonna be S of B minus S of A over B minus A. Now that's only if S of T is giving. Because I don't have to give you just only an S of T. Okay? Brenda, pay attention for a second. So now here is second definition is 1 over B minus A integration of V of T A to B dt. That is equal to also a average velocity, but is velocity of time is giving. So I can give you velocity and you can find average velocity, or I can give you a position, you can find average velocity as well. Is this okay? Okay, we finished that, but average acceleration. What is average acceleration? What do you think is? If average velocity is changing position over changing time, what will be average acceleration? Changing velocity over changing time. Good. So then that will be V of B minus V of A over B minus A. A lot of people thought it's average velocity because you have V of B, but no. You are changing velocity over changing time, therefore it's going to be the average acceleration rather than average velocity. I also would like to mention speed. Did we mention speed yesterday? Speed is equal to absolute value of V of t. Now, why that is? Now, I'm going to explain to it in a second that you can understand. Velocity has a direction, has a vector. So let's just say if I'm going this way, it's positive. Then if I'm going this way, it's going to be negative. So it has direction. So let's just say if I'm going forward 2 steps per second, so my positive is 2 steps per second. But if I go backward, then it's going to be -2. But then if you talk about speed, it's going to be, doesn't matter which direction you're facing. It'll be 2 steps per minute or per second, whatever, right? So this one has no directions. Now V of t, it has directions because it's a vector. Vector means you can go this way, it's positive, go the opposite way, it's negative. Is that okay? Is this okay or no? Now I would like to talk about one next thing, which is the difference between this. So what do you guys think this is? Integration of V of t of A to B. What? No. No, there's a definite integral. It's a definite. What's the integration of A to B of V of t? No. Where's the integral go? What's the integration of v? S. So will be what? S of b minus a s a. So that's known as total. Sorry, not total. It's equal to displacement. And you're gonna be like, what is displacement? Well, displacement is a difference between the position at time b minus the time a. So the difference between two positions. So at this time, I at the walk ring, and the next time will be like 10 minutes later, I'm at Walmart. So what's the distance between Walker and Walmart? Well, let's say it's 10 miles, and that will be 10 miles. So that will be a displacement rather than a thing. Now, there's a difference between displacement and total distance. Okay, there's a small difference. So I'll give you an example so that I have to show it in front of here because so I'm gonna go here, right here, right. Okay, so that's me. That's Fabian. Oliver, you look good. Damien look good here. Okay. And this is the me, right? So there's slightly difference between displacement and total distance. So what I'm saying, I'm pretending that there's 5 seconds, and each second I'm gonna take 1 step. Okay. So what I'm gonna do is I'm gonna take 1 second. I'm taking a step forward. 1, 2, 3, and stop. Right. My velocity is positive. Okay. So in 3 seconds, I take 3 steps. Right. And I take step back, and I take step back. That is my final position. Compared by initial position, what's this is a displacement. What is that? 1. So that means this is 1. Does that make sense? Yes. So that's total, that's displacement. But then you say, well, what's the total distance he had covered? So that means I'm taking 3 steps forward, 2 steps back. I'm gonna add them together. Even though it's negative, I'm gonna add them together, so it's 5. So total distance is 5. Displacement is 1. Is this okay? Okay. So I'm gonna show you in terms of graphing. Okay, I'm totally show you in terms of graphing. In graphing, I'm gonna show you here. In graphing, it's gonna be wait, how come it's not switching? Oh, it's switch. Okay. All right. So then, in terms of graphing, that 5 seconds just happened. It's supposed to look like this, and it will show you that you can understanding the difference between two. So the first 5 seconds, I have velocity of 1 step per minute. So my velocity is positive. So this is, sorry, my velocity is positive, right? So that means I have this. Is that okay? Because I have, this is velocity, this is time, right? Now at the second one, I have a negative velocity. Negative velocity, I take 2 steps. Is that okay? So now if you say, hey, if I integral v of t dt from a to b, that's going to be 1. Because it's this area, right? This positive area here, minus this area. Does that make sense? Now, if I were to integrate, if I were to say, hey, That's integrate a to b of absolute value of v of t dt. What will happen? That means this part here is going to move upwards. Right? And that's equal to 5. Does that make sense? Visually, does that make sense compared to the graph? Huh?
In the second integral, what did you change?
In the second integral, okay, so this is the first integral. The first integral is because the function is negative, because I take 2 steps backwards, right? So my velocity should be -1. Does that make sense? If it's -1, then it's going to be, this is an example of total displacement. Or actually call it displacement rather than total displacement. This, however, this one will be basic absolute values to make the graph go up. So it will go this graph here, and this graph was down here, it went up because absolute value making the negative becomes positive. So therefore, this area is 5. Does that make sense? 1 is 1, 1 is 5. Total displacement is without absolute value. Total distance is. Okay? One last thing I need to talk. I need a strong volunteer. Like, who's strong? Larissa? I know Larissa is strong, but I need a boy.
Maybe.
Okay, Damien. Damien's strong. Damien's like a bus. Okay, so what we're gonna do is we need Damien. We need to borrow Damien here. Alright, Damien, come up.
Yeah, Olympian was strong.
So what's this way? Go this way. Damien, go that way. Okay, good. So we face each other. Okay. So that says Damien is a bus. Okay, Damien's a bus. It's going this way. You guys can see it from this side. You guys can see? No problem. Okay. And let's just say this is a stop sign. And there's a child over there. Okay, there's a child over there. It's on a stop sign. And like he's crossing the street. And there's a bus coming over. And the bus is going 30 miles per hour without a brake. Okay? So Damien is a bus. Now let's categorize this. If the bus going this way, that's a positive velocity. Is that okay? If you're going the other way, it's a negative velocity. Is that okay? So he's going positive velocity. And I saw this child, I'm a Superman. What do I have to do? I have to stop the bus. I have to find a way to decelerate the bus. So right now, we're going to talk about speeding up and slowing down. So, guys, pay attention. I'm talking something very important. So, if the bus is going positive, so that means if the vector is positive. Is that okay? How do I slow him down? I had to push the other way. So the bus coming, go ahead, come. Right? So I had to push him back. I had to push him back, right? So my acceleration is going this way. That's caused him to slow down. Does that make sense? Is that okay? So they have to have opposite. Now, soon as this bus coming this way, and then after the stop sign, I need to make sure he get off the road so nobody the other way. So he had to go a positive velocity. His brake paddle doesn't work, but his gas work, right? So gas can work, so I can push him off to speed up. So now my acceleration is positive, my velocity is positive, therefore speeding up. Is that okay? Fair? Now on the way back, same thing. Now his acceleration, his velocity is what? Negative. Now how do I come on? I have to slow him down. I have to be going this way, right? Does that make sense? I have to go this way. So even though it's negative, my acceleration is positive actually. Even though he's slowing down, but my acceleration has directions. Is that okay? So here's the thing. If you're speeding up, then your acceleration and velocity have same sign. If it's same sign, it could be both positive or both negative. If you're slowing down, then one of them is positive, one is negative. They have opposite signs. Does that make sense? That's help you solve number 8. We didn't get to do number 8, so you have to do 2 number line compared to number line. Now with question 2, you have to do only 1 number line on the second derivative. So number 2, the answer is actually E. Okay, the answer is actually E. Thank you, Buzz. Is that okay?
Accelerate, does it always have to be like the opposite and negative?
Yeah, you have to compare velocity and acceleration. So I'm gonna write it down for you. That way it makes sense. That way it makes sense. Sorry. I'm gonna go back. And send a video to Greenwald. So that's how you teach physics. I'm just kidding. I'm having fun. I don't care. Okay, so there's a difference. If today I ask you the velocity is increasing, then you just take derivative, which is velocity, and take another derivative to find it increasing and see using number line. But if I say speed is increasing, it's different. Speed is increasing is asking you to compare both velocity and acceleration. So I'm gonna write down speed increasing. You have or decreasing. Sometimes we say as speed up or slow down. Now in this case, both acceleration and velocity have same sign. The second one is A of t and V of t have opposite sign. So you have to compare. If I say speed is increasing or speed is decreasing, this is how you compare. You compare acceleration and velocity at the same time. Does that make sense? Now, if I just say velocity is increasing, so velocity is increasing, then you don't compare. You just so velocity, then you say s prime of t, and then you go to s double prime of t, and you do number line test. Number line test. But the second way usually less likely to ask. They usually ask speed up or slowing down. Is that okay? Speed up or slowing down. Is this understanding? Okay, so those are all the things that we have additional talk about the other day as SVA. So position, velocity, acceleration is taken derivative each time. And if you want to find the other one, you have to integrate each time. So this is how you do this. Is that okay? Yes.
So when do you make the number line?
Number line test you need for both. So I'm gonna give you an example. For example, the question 2. Can somebody read me the equation for question 2? Question 2 is what? T to the 4 something, right? Minus what? 6t squared plus what? 8. Okay, so this is s of t, right? Now, number 4, I can ask you 2 different ways. The question is asking you velocity is increasing. Well, first of all, let's find the velocity, right? So velocity is increasing will be 4t to the third minus 12t, right? And if increasing, that means I have to do one more derivative, right? So b prime of t, that's equal to 12t squared minus 12. And now just do a number line here. Why do I do a number line? Because you want a 12t squared minus 12 greater than 0. So that means you can factor out 12t squared minus 1, which is t plus 1, t minus 1. And between -1 and 1, this one's going to be both negative, and a positive negative, and positive positive. So the problem is we only take account into this part. This part is all ignore because t cannot be negative, right? T is always positive. So in terms of number line test, you only care about from 0 and on. Is that okay? So then you said the answer is going to be 1 less than t less than square root 3 because that's the best option. Because that's make sure velocity is positive. You don't have to compare acceleration and velocity. Now, if the question asking differently, the question is asking you, hey, what is slow down or speed up, right? Speed up or, right? So when does slowing down when speeding up? We can tell that. So if I go ahead and take the velocity is going to be 4t to the third minus 12t, right? If I do acceleration, see, I didn't do v prime of t because v prime of t just told me increasing and decreasing, but they stand the same thing. So this is 12t squared minus 12. So you have to do 2 number lines. One is a v of t. And so v of t, you have to do number line. So before I do number line, what do? I have to figure out what the endpoint is. So it'll be 4t times t squared minus 3. Is that okay? And then it's going to be 4t and t squared minus 3. We start at 0. We don't worry about before 0. Square root 3, huh?
Factor 12t squared minus 12.
Yeah, I factored.
4t.
I factor out 4t from here.
Oh, okay. Yeah.
Okay, so then I will have positive, positive, and this part I will have negative, positive, so it's positive, negative. Is that okay? I will do a second derivative, which is we already did before. We know that it starts from 0 to 1. Wait, sorry, I want to do it in same scale. So 0 to 1 is a little bit less than here, so it's 1. And I here is going to be negative, is a positive, right? Now, can you tell me which part is speeding up? Can you tell me which part is speeding up? Three onward, okay, 3 to infinity. What else? Because they're both positive. What else? From 0 to 1. Why 0 to 1? They're both negative. When slow down? Do you see slow down? I see slow down here.
1 to root 3.
1 to root 3. Does that make sense? Because it has a positive here, it has a negative here. Between here and here. Do you see that? Square root 3. Does that make sense?
If they're the same sign, after.
Yeah, because you can go backward. The bus can come back and still send children there.
Okay.
I gotta stop. I gotta put opposite. But after those children, I can push them away, right?
Either you solve it that way or this way.
No, there's two different questions. This is the velocity is increasing. You want to find out when velocity is increasing, then you take a velocity first. Increasing, you do a second, you take another derivative, see the positive region of the number line. At speeding up or slow down, you compare velocity number line versus acceleration number line.
Okay, for when velocity is increasing, how do you get that answer?
Because is here is a positive. Because I take a derivative of velocity. If I take a derivative, it tells me increasing or decreasing. So I only had to do one number line because I only look at the velocity.
Where'd you get square root of 3?
Yeah, that one because that's the best option. It should be 1 to infinity. So if the correct way, it should be 1 to infinity. Like this. But that was the best option, the only option that applied. Did I help you solve thinking how to do number 8 now? It says speed is increasing and number 2 is the velocity is increasing. So there are two different style questions. You had to recognize which one's which. Is that okay? Okay. So let's look at your homework. Let's tell me which question that you guys may have. Yes. 12. 12 is lovely. Sure, I would do 12. So 12, 12 question, 12, you had to take a second derivative. The reason why, because they give you a position function. But when you take a derivative, that I will assume that, Damien, you probably have a hard time with the chain rule. I don't know if you take a derivative correctly, but there's a chain rule involved. Because if you take a derivative, this is the first derivative, this is the outside function, there's inner function there. So if you take a derivative 4 cosine pi over 2t, it's going to be negative 4 times pi over 2 times sine to pi over 2t. Because there's a chain rule involved. This is what people usually forget on this homework, is they forgot the chain rule. How many guys forget the chain rule? No? Okay, you know how to do that? Good. And then you have to do it again. Set m equal to 0. When you set m equal to 0, you're going to get to this part. Then you're going to say, wait, when is cosine equal to 0? Cosine equal to 0 is pi over 2. So it's going to be pi over 2t equal to pi over 2. And then t is equal to 1. Once you find 1, you have to plug in to find a v of t, because they say, what is the velocity of particle acceleration first equal to 0? They did not ask you what is the time when the acceleration equal to 0. They ask you what's the velocity when the time equal to 0. Questions? Is all good? Okay, this is another question people ask. Number 4. It's 36. Did you really get 36? Yeah, because technically, you're supposed to do a number line and you're supposed to do a table, technically. But in this case, 1 is actually relative minimum. So that doesn't really help you. So I just do the table 0, 1, and 3. So I got 36 is the final one. Next question. Samuel, no question? Number 8. Number 8, you should get B. If you do it correctly, you can try it now. This is a question we didn't get a chance to talk about because it's speeding up. They say speed is increasing. So you have to do 2 number line to compare. Did you guys do 2 number line to compare? You have to. You have to do 2 number line to compare. So compare right now, see if you got the same answer. Question 9, I got negative 5 over 2. This one's kind of tricky, but there's a lot of chain rule involved. That's what I got.
Go over 3.
Sure. Average velocity. You have to know average velocity because position is given. If position is given, then I have to change the difference. So I had to plug in 3 pi over 2. Now today, this morning, I did do the question. I got 3 square root 2 over 2 plus 1. But I forgot to plug in s of 0. I was like, wait, the answer's not there. So I was like puzzling. But I forgot to plug in 0. If I plug in 0, I got 1. So 1 and 1 subtract each other. And you'll end up 3 square root 2 over 3 pi over 2. And then end up everything cancel out. You're going to get square root 2 over pi. I got square root 2 over pi. What'd you guys get? Good. You guys do an excellent job. Pick one. It's not bad.
Can you go over like one of the table ones? I don't know what number.
Which one? This one?
Yeah.
Yeah. So this is velocity. Velocity is the slope of position. Because the table is a position, you just have to find the slope of those 2 points. This is actually a good AP exam question. I see this all the time. This question is very common. Yes. Can I do 7? Sure. Let me see 7. What is a acceleration? The particle time. Oh, just plug in. Take a second derivative. Did you do that? So v of t is equal to 2 plus pi cosine of pi t. And the a of t is going to be 2. Take a derivative of 2. It's going away. So it'll be pi squared negative sine of pi t. And plug in sine of 3 pi over 2, which is negative 1. So it's going to be pi squared. D. I got D. Yes.
So we always take a second derivative first.
Depending on which one's given. If I give a velocity, it will be first derivative. If I give a precision, so it's SVA, S of t, V of t, A of t. So this is positions, velocity, and acceleration. So if you go in like this, you take in derivative respect to time. Is that okay? If you going up, is you take an antiderivative. Antiderivative, which is integral. Which is, you have to worry about plus c though, because sometimes you have plus c you have to worry about. Next questions.
Wait, Mr. Yan, how'd you get pi squared per second? Like,
Because sine of 3 pi over 2 is negative 1. Negative 1 times negative pi squared is equal to positive.
yeah. No, like, how'd you take like the when you did the derivative?
Chain rule. Chain rule. The pi squared is just a number, has nothing to do with it. So when I take a derivative of pi cosine pi t, it just get another pi, just it becomes negative pi squared. And then just take a derivative of cosine, which is sine. And then just plug in 3 over 2. Yes or no? Let me see 14. 14, I think the only option I can do is do a slope between those 2 points. But I think this one's missing a last coordinate. I don't know. So force disk is gonna be 0.8 over 0.5. So that's 1.6. So C. I can only do it to those 2 points because that's closest to 2. So I find the slope between those 2 points. I don't want it between 0.5 to 2 because it's too far. I want a 2 closest point. Because I cannot take a derivative, right? The best way is to find slope. So slope or derivative. In terms of slope is approximation of derivative. But this one is a function, so you can't really, this is table, you can't really take a derivative, right? But you can take a slope. Next question. I think homework today is posted, right? No? Yeah, I post on time. Wait, no, I didn't. Hold on a second, let me turn on VPN. So now it's posted. About 3 of those pages are multiple choice. Rest of them just F4Q. They do only the easy one. Yes. What's the name? Can you teach them how to get pi 2? Yes. Pi square. No. We have all the slope field, slope field differential equation, and all the derivative technique. Derivative and integration technique we can finish. It's easy to act natural. We will finish before March 10th. Ideally, yeah. Because I know last week of school is which is so hard. Right now we already start doing it. Yeah. I assume. Max sounds pretty smart. It's not pounds. I have moments. You have moments? And you have other moments. I do. Wait, do you guys want to do math competition this weekend? No. Oh, when this weekend? 9:30. No, 8:30 to 12. But for you, probably take individual because most of PC is taking the team. Okay. So just do it individual. But I think you guys will do well. Anybody want to join math competition this weekend? I'll see if we can do it this weekend. You let me know. Hannah, want to do a math competition? Miranda? If we did AP practice. No? Hannah says no. Huh? You're running what?
We're doing the Titan trot.
Running what?
The Titan trot.
What is that?
We got for the girls soccer team, right? Yeah, it's like a 5K. I'm not good. We're too good at rugby.
Yeah, that's what I'm saying. Yeah, make it a horror. Like, yeah. Make it a
Are you, did you pay? Oh, me neither.
I need volunteers this weekend. If you guys want to volunteer, I can give you 8 hours. Huh? Sure, $2?
Wait, I got
I can afford $2 an hour. $2 hour? $2 hour. I can afford $2.
This pie was here. And then negative one.
You're gonna find the slope of the triangle, it's always decreasing. You're going to find which function is always.
Oh yeah, I'm marrying it. I think, yeah, I think what exactly it is. I mean, like a trap plan. Oh, I respect it. No, I'm
Just cause dearly,
And we have time for it.
and we have practice on it.
No.
I don't think I'll move to that one. I think that's where Kana's involved. If I move anything, I'll probably move to China so I don't involved. Even though I don't. And I don't agree with America because what they do in Venezuela. Yes, America's like almost turning to like third world country. I feel like I feel like it's
Yesterday was 1 year.
Really?
you don't like it. Why you don't like it though?
I don't like it here.
Why?
Saudi's way nicer. Like, not only like
Propaganda.
quality of no. Here it's propaganda. You should see how Saudis see America. They see it as this heaven. Like you're going to study in America. Like they're so good. If you just show them that you have a certificate from your diploma from America, you get any job you want. Like they die for
Yeah,
anything called
That's what
America.
my friend told me.
But then on the inside, the quality of life between Saudi and here, it's so different. Saudi, it's way cheaper, and the quality of life is just so much more luxurious than everything. Like, if you go and see,
No, that's true. Like if you go to China, right? People are always like propaganda in China.
yeah,
But if you go to China, they are so fucking advanced. They are like way more advanced than
here you use like all the fiber for the Wi-Fi and you see the electric stuff. You never see that in Saudi. It's all hidden, it's all neat, it's all organized. Like it's made so it's pleasing to everyone to live. And it's just way more comfortable. You get anything you want at your door. You have everyone has drivers, everyone has maids, everyone has nannies. Like it's cheap, everyone's important.
Yeah, and all the imports of it.
everyone to do with the water.
Oh, it's so cheap. We have a driver and
It's the only one, like, it's like, the question's like, okay, what's the difference like, between all the, like,
No, but the problem is we fight over the Saudi.
and then all the entities have to be wealthy. We're talking about something that's Colombia's like, shit like,
From 0 to
no, it is Eastern West.
you're 4 and 5. You can't say that. You're 3. It's 4, 8, slot 1. You are the
I don't.
like all my friends, average parents work normal jobs. Everyone, like everyone had a maid, everyone had a driver, everyone had everyone. Now life is getting more expensive there. But these are my average friends. If you want to talk about rich friends, they have schools in their houses, they have three cooks in their house, a driver with their children, they have an elevator. That is what they call travel. Like, this is what
Yeah, I was like talking about the Valley Match.
they have companies all across the The thing there is for a foreigner to, it's hard for foreigners to
That's pretty good. Okay.
Because I felt separated from like that's what we're undo. So it has to be the rock. Oh, is that right? Like it's always under the line because that's the dirty. Like is that like that? So it has to be under the ground. That's over. Okay.
Where did you live in Saudi Arabia? What is Jeddah? Is that like?
No, it's like it's nice.
Dude, we're nowhere close to that.
Not nice.
Or
I
Lebanon?
think it's not.
Like the freedom of speech, but right
Okay,
now
we don't have that either. That's the problem. Is I would give anything to live there, and I don't mind the not
the
having.
freedom of speech.
Yeah.
Okay, so in China it doesn't have freedom of speech, but as long as you don't talk too much shit.
Exactly.
You talk a little shit is okay.
Yeah.
You have to the government's stupid, and that's okay.
Exactly.
But if you put on internet the government's
They
stupid,
will find
and
you.
they will find you.
Same thing as that. If you say anything bad about the government, they will find you.
Oh, what's that prince? That prince?
The prince, yeah.
He's a dictator. He's like he is a cousin to the dog.
He wants to
think that dictatorship is better.
I didn't say that. No, I didn't say that.
Did he be his cousin to the dogs?
Oh my god, the family drama is actually there is one killed his brother because his brother was gonna be king,
Yeah.
and one
They like feed it to the dog.
yes, yes. I think that's real.
It's just family. Oh no, are you still infectious? Stay on the side, stay on the corner.
It's weird. I haven't been sick since like last week Friday.
Oh, okay. You're clear.
Yeah,
I was so pissed about Ina. She was like shouting at it.
I don't know if she didn't hear today.
Good. It's not here, it's good. I don't want her here.
Yeah,
I don't know why she's shouting. Just go to the corner. Piss me off. I literally go home, I feel like sick right after this class too. I was about to strangle, I was like, ugh. Yeah, I'm gonna stay in my corner. All you infectious people. Peter flu? You call it Peter flu. Peter flu. Now the other Aiden got it in my sixth period because he talked to Jesus. He talked to Jesus Friday, and I think Jesus is not completely done yet.
Yeah, I don't know why like a lot of people come for Friday. I made sure not to show up.
To skip the test.
Well, if I just could not get my mind around that, that was one. Maybe that's the homework I said, dude. Yes.
Also, you need to go over to the test.
Yes, I know of that.
Okay.
Yeah, do it fully because by the time I was done with that and the homework for other classes, it was 9:40.
Okay.
But you can see that I did finish both pages. I just have the
What's up?
second one later.
You got my receipt, right?
Take a picture of it too. As a receipt. They didn't have any good bananas that would last.
Water. Wait. How did you buy? Why so cheap?
Because they had it was 35 packs. Packs of 35. So instead of
35.
I got 105 codes.
Yeah. Well, we got water, so.
You said that you needed 87. minimum.
Yeah, but we have to estimate a little bit more.
Estimated more. Okay.
That's okay. Whatever. Whatever is shorter, we just find a way to do.
I could, like, I'm going to try this order chicken certain at the end.
I'll tell my wife to get it.
Are you sure? Okay.
I'll tell my wife to get it.
When do you want me to grab it?
After school, we pick it up a couple of kids.
Because it's in the car.
Who's
not doing it?
Claire, Misha. Claire's good. She always score 100 on the test. She just don't have the confidence to do it, but Claire's really smart. But if I somehow, if Claire cannot do it, it will be Misha, because they are smart. Yeah, and also Raiden. If I really want to put Raiden, might be smart. Raiden's actually really smart.
He is smart. He just doesn't. He's lazy.
No, he's not lazy for me anymore.
Not anymore?
I used to hate him. I used to hate him a lot in Freetown. I hated him a lot. And then when Kalki was actually become very good at the second half. And then this year he's been on top of it. He just mentioned it's like, oh yeah, it's so good.
Speaking of homework, was there homework last night? Because I didn't get any messages. Like, I checked this morning. I think I saw something.
Hello, Mr. Yang. Two things. One, did you see the brochure?
Yeah, I need to finish up. Oh shit.
No, I think right?
Yeah, I need
It's done. Do you need me to change anything?
I need to make sure with the runes. I'm looking through it.
And then the other thing is I have a joke for you on here. Wait, this is actually might be good. This might be good. Wait, no, I have to see your face. I have to see your reaction. Okay. So I get on stage, right? I'm like, hey guys, like, welcome to Magical Music. Like, hey, like, I look and feel really bad for algebra students because they're always like, dude, I'm trying to find my ex, but like, she's not coming back, and don't ask me why.
I heard that one like 10 years ago.
Do you get it?
Yeah.
Don't tell. That's all
You're gonna hear cricket.
okay.
You're gonna hear cricket.
Not a bad day to have a free out. Fine for me because I got one everybody fucking. He said if you assign I don't know, I guess.
Oh my gosh. Open it. What?
I was gonna say, I was like going to the morning.
So,
Kimberly won.
We're gonna start out from the front. All right. My guess. You're gonna end up watching. Oh, no.
It's with the total
Why can you put it in?
I got that one. Do you want me to do No, like literally, yeah.
In your neighborhood, and she was like,
What? Yeah. Yeah, we can pull up. All AI, get free mode.
they have the
Bob, did you text Henry? I texted him, I don't know.
What can I bring to the table when I am? Can I bring to the table when I Oh, wait. I brought something. No.
All right. Homework, everybody should have not too much problem, right?
Yes. Wait, could you go over number 17?
17. Can somebody do 17 on the board? Okay, 17 on the board in the back. I don't know.
Wait, okay. I have every single one. I need help. I'm gonna check how we. So it is the role of. Very last day, you can help me. Yeah. If you say it's not on its own, we can use it. Mr. Ye, what are we doing tomorrow?
Huh?
What are we doing tomorrow?
Teaching.
Let's have Raleigh.
I'll be teaching.
Improper practice.
Proper integral.
I knew it. Hi, Mr. Ye.
No, I can teach now. You don't want to come tomorrow?
Yeah.
I mean, if you don't want to come tomorrow, it's fine. Because I'm already grading the test.
You won't put it on the oh, we will review the test.
Why?
Because I'm going to yell at you.
Can we grade the test tomorrow?
Huh?
Can we grade the test
Yeah, we're gonna grade the test tomorrow. What? Peter not showing up? He should have not shown up last week and all the people infected.
God, Boston.
Peter flu?
Yeah,
Peter flu.
Peter flu, better known as influenza A.
The influenza P. Influenza P.
You know, you can thank Nizar. He went to the doctor for me because I wasn't going. So I told
doctor for you?
and Aiden. He told us all what we had. Doctor messed up. There's no shot he didn't have to see. The Popeye chicken has nothing to do with it going on. Oh no, Aiden has something else. But I don't know what it's like.
All right, so shh. I'm gonna go into improper integral because there's math competition this weekend. I want to finish all the improper integral technique first, and then for those of you guys doing competitions, anybody else want to join? You are welcome to join. Hello? All right, so what we're gonna do is improper integral. They're very, very easy. Don't worry, they're really easy. So, improper integral is if you have a definite integral and the boundary is gonna go to like it's going to like something that's either infinity or some value that's going to become undefined for x. Okay, so we're gonna look at improper integral and make sure you have to write it properly. Improper integral. And so definition of improper integral, if you have, let's just say a to infinity, like this, f of x dx, you must write down, because the infinity is not a constant. So the way to rewrite this, it just says, well, it's integration from a to b. And so instead of write down infinity, you're going to write down b, right? And you also going to write down in the front, says limit b approach infinity. B approach infinity. And this one's going to be f of x dx. Okay? So instead of write down, so the bottom is constant for sure already. So you can write the top just normal b. And in the front just says limit b approach infinity. Okay? So now what we're going to do is also there's sometimes you're going to have a negative infinity, which is sometimes you could have this case, b and negative infinity of f of x dx. Then you can write down as b to a of f of x dx, and there'll be limits as a approach negative infinity. So basically, this part you cannot miss. On AP exam, you gotta make sure you have this part, you have this part. Even though people can just kind of do it without it, you have to write it down for the AP exam knows that you know how to take an improper integral, which is it says limit approaching infinity.
That's an A, right? A is going to negative infinity. Right?
Yeah.
Yeah. Okay. And that's from A to B.
Yeah.
Okay.
Because I replace a as it replaces negative infinity as a. Now, if you have a negative infinity to infinity of f of x dx is equal to negative infinity to c of f of x dx plus c to infinity. Of f of x dx. So we can break up to two separate integral to form a constant. So let's just say if it's negative infinity to infinity, you can say it's negative infinity to 0 and 0 to infinity. Does that make sense? You break up to two separate integral. Now, if the limit exists, then it's converged, then it exists. If it's diverge, then it doesn't work. Just say it does not exist. And just say infinity. So in the first two cases, the improper integral converge. So if they converge, if the limit exists. Otherwise, the improper integral is diverge. So you can say it's diverge. If it's going to infinity, it's going to be diverge. We're going to go through some situation that you're going to say is diverge. So we're going to give you an example so that way that you guys know what's going on. So let's just say integration from 1 to infinity of dx over x. So instead of write down this infinity right here, we're going to say it's b. 1 dx over x when limits b approach infinity. Is that okay? Is that okay?
Yeah.
Now that is going to give you ln of x from b to 1 when limits as b approach infinity. So then you say limits as b approach infinity of ln of b minus 1. What's ln of infinity?
Good question.
Well, if you have really large number and you do ln, it doesn't matter. It's still infinity, right?
Isn't LM1 0?
Oh, L1, yeah. So this one's diverge. Because go to infinity is diverge. And this one comes matter later. Because this one, data, you're gonna have a P series. Okay? Involved with P series. That means the integral from 1 to infinite. This area, even though it's getting smaller and smaller, it's still increasing enough when it goes infinite. Or is this infinity is diverge? Okay, so this one is still going to infinite, but that's weird because if it's less than 1, the x is less than 1, so it's 0.99, it still diverge. But if it's 1.01, it actually will converge. Weirdly, if today this x is more than 1, slightly more, even 1.01, it will actually converge, which is you will get a certain value. Okay, you will get certain value. But it's diverge, then this is just always gonna grow. So this is gonna become matter. So later we're gonna talk about this. Talk about it at P series. And we're gonna say it's P series. What is P series? Okay. No, P series is different. P series is when the P is greater than 1, then it's going to be converge. Okay, so I want you to do one of this: 0, infinity, e to the negative x dx. Very simple integral, nothing crazy.